Hello! Now, today we are going to continue on with our work in sets, and we're going to be looking at Venn diagrams using them in a slightly different way. So this is another good general principle in maths. We have this really useful tool of Venn diagrams where we can draw pictures of what we know about our sets and use that to solve problems. And now we have another way of using that tool of Venn diagrams to solve a slightly different style of problem. So let's jump into it and have a look at the question that we are going to deal with. So we have 30 students in a class. 20 of those students do geography, 25 of the students do science, and 17 do both. So let's have a look at what that is going to mean. We're not told the names of all 30 students. We're not given the elements of the set. We're not given the students in the class. We're just told the number of students in the class. That means we're dealing with cardinal numbers. Now, everyone we talk about in this question is in the class. So that means that the number of people in the class is our universe. So the cardinal number of our class is the cardinal number of the universe, because everyone we're talking about is in the class. That means that our universe is the class. So the cardinal number of the universe, or the cardinal number of people in the class, is going to be 30. Now the cardinal number of people doing geography we might call cardinal number capital G, capital letter, or for the name of a set, is 20. Cardinal number for capital S for science is going to be 25. And the cardinal number for both, well, what could we do there? We don't just want to put that in cardinal number or capital B, even though we could. There's a better way to write that. What do we know in sets when we have elements that are in both one set and another set? So we both do geography and science. What way of describing that do we know already in sets? Well, we're looking for a number of people, so it's definitely cardinal number. And then cardinal number of what? We want to do geography and science, both of them. So that means we have geography, intersection, science. Geography, intersection, science. So these are the people who do geography and science. And that's 17 people. Now let's see what we can learn about when we draw a Venn diagram of that. Because there's a question that I've got in the back of my mind as I am thinking about this. I know there are 30 students in the class. I know how many are doing geography and science in both. Something I don't know is, are there any students who don't do either of those subjects? So that's a question I've got, and with the information I've got here, even when I've translated it into maths, I can't see immediately whether there are students that don't do either subject. But if we draw a Venn diagram, we'll be able to figure it out. So let's see what we can do. What we're going to do is draw out our box for our universe. Because remember, the universal set is our special set, so instead of drawing a circle, we draw a rectangular box. And we have the universe. And when we're doing cardinal numbers, what we can do is say the name of our set and then draw a square bracket. Not a curly bracket like we had elements, but a square bracket for when we're dealing with the cardinal number here. And we have the cardinal number of our universe is going to be 30, because there are 30 people in the class, 30 students in the class. Then there are 20 people doing geography, so I have G for geography and in square brackets 20 next to that. And then science, I have 25 people, so I have square brackets 25. Now, anytime I'm doing my Venn diagrams, I'm always going to try and start filling in the center of my Venn diagram. And happily this time I can do that fairly easily because I know that G intersection S is going to be 17. The number of people doing both geography and science is 17. Now I've got that in, I can fill in the rest of my diagram fairly straightforward. Why? Because I have a total of 20 people doing geography. So inside this circle, inside my little boundary here, inside my geography boundary, there's a total of 20 people. Now 17 of those 20 do science as well. So how many of the students in the class only do geography? That's going to be 20 minus 17. So there are only 3 people left who do just geography. And if we look again, we have the number of people who do geography would be 3 plus 17 would be a total of 20. Now let's do this with science. Again, we're starting in the middle and we're working our way out. So we have 25 people in total who do science. 17 of them are doing geography as well. So how many of them are only doing science? Well, that's going to be 25 people minus the 17 who are also doing geography, and we are left with how many people who only study science? That's going to be 8. So there are 8 people who only study science. They don't study geography. Now that we've gotten the center of our Venn diagram sorted, we can figure out the final part, because we know in total there are 30 people in our class. So there's a total of 30 people in our class. And we know that 3 of them study geography only. 17 of them study geography and science. And 8 of them study science only. Now if we add up the people who study only geography, the people who study both geography and science, the people who study science only, and the people who don't study either of them, we have to add up to 30. So if I add up these things here, I have 3 plus 17 plus 8. When I add all of that up, I end up with 28. So there are 28 people in here. There are 28 people who study geography or science. And there are 30 people in the class. So how many of them don't study geography or science? Well, it's going to be 30 minus 28. So there are going to be 2 students who don't study geography or science. There's going to be 2 of them. Now you can see when I've written this out here, I have a 3, a 17, an 8, and a 2. And there's no dot next to any of them. The reason for that is that we're not writing down elements. So if we remember back, so far with Venn diagrams, we've been drawing in dots for our elements of our sets that we've been putting inside of our circles. But this time we're doing something different. This time we're writing down the number of people in a group, not their names, not the elements of the sets, but the number of elements in a particular part of a set. So that's why we aren't putting in dots, because we want to show that we aren't talking about the element 3, we're talking about there being 3 people in this part of the set. So that's why we haven't written in a dot next to our numbers. Now let's see if we can write this in a slightly more mathematical type way, because I've just written down numbers randomly almost on the page, and we want to get into a stage where we're able to use maths properly. We're able to use maths to describe what we're doing. So let's take this. We have the number of people in the universe was 30, and we want to take away the number of people who do geography or science. Well, what's the number of people who do geography or science? That would be geography union science. So we're taking away the number of people who do geography or science. So remember, union means or, away from the total number of people in the class. So that's what our sum becomes. And this is where we really want to be going, that we can describe what we're doing in mathematical language, because we're going to have to do this when we come to something called algebra, which is when maths gets really fun and really good at solving big problems. But you can start to see here how if we can describe things like this, we're going to be able to solve more complicated problems and more problems in general. So we know the number of people in the universe is 30, and we know the number of people in geography union science is going to be E3 plus 17 plus 8 is 28. So we're left back with the sum that we had before. And we know that there are 2 people who don't study either geography or science. So this piece here is really important. We want to be starting to get ourselves in a position where we can use this kind of language to describe what we're doing. Now, this is the idea of our Venn diagrams, when instead of writing down each element in the set, we write down the number of people or the number of objects in each part of the set. And that is what we need for solving our problems right now.